So hello everyone, and welcome to the webinar in the Language Technology webinar series. This is organized by IT, the Basque Center for Language Technology. I'm the director. This is a research center for those of you who don't know. It is located in the Basque Country in Spain. And we organize this webinar series in conjunction with our Deep Learning for NLP course and the Language Technologies Master. Esther, pasa por su transparencia, Mercedes. So, oops, there's something. Yes. Aurreko transparencia, Mercedes. Sorry, I don't have the control over the slides, so that's why you need to start. Yeah, by share. So in this webinar series, we had talks from all the great researchers that you can see there, and it's and I have to say that we are really excited that today we are having Pascale Fung. Pasa tu Esther, Mercedes. And she's going to talk about safer generative ConvAI. I'm sure you know about Pascale Fung. I have known her for many years because of her great research on natural language processing. She's, I'll briefly summarize that she's a chair professor at the Hong Kong University of Science and Technology, and also visiting professor at the Central Academy of Fine Arts in Beijing. So she's been elected fellow of the most relevant associations, including AAAI, ACL, IEEE, and also ISCA. She's the director of the Center of AI Research and also founding chair of the Women Faculty Association at her university. She's also advising the World Economic Forum and the Partnership on AI to Benefit People and Society. And she's in several boards. And I'll stop here because I'm sure Pascale has other, as you see, other responsibilities. But we mainly invited her for her great research and also because she's been working and doing very innovative research on generative AI. So, Pascale, whenever you want.
Muchas gracias por invitarme. I'm going to share my screen. I'm very honored to be invited here. And here, can you see?
Yes, we can see your slides.
So the topic today is safer generative conversational AI. Before I start on the subject, I always like to do a little bit of high-level introduction. I think a lot of us have heard all these terms a lot: beneficial AI, ethics of AI, responsible AI. So beneficial AI, everybody knows, it's the AI applications that benefit humanity and society. Ethical AI are systems applications that satisfy ethical principles and standards, which there are many today. And the ethics of AI is the study of ethics related to AI development and applications. What we are talking about today is actually within the realm of responsible AI, which today is considered operationalizing ethical AI with science and technology. So how do we implement ethical AI is considered responsible AI. This is a convoluted kind of diagram, but actually it's not that difficult. You can see like these arrows going everywhere, right? Number one, we have the regulators and laws and policymakers who are actually, regulating the standard bodies, the developers, the users, and almost everybody. And they get their information from researchers and ethicists, from representative of a development community, the standard bodies. The users, of course, have feedback. They're using the systems that the developers develop, so there's user feedback to the systems themselves. And then you see all this kind of gray lines, arrows. The standard bodies will issue guidelines that will then be adopted by developers, some users. And then the developer system that they develop will be then used by the users. And what you see is that the researchers and ethicists will publish and give talks and so on. They publish and they make models, data sets, codes, and so on, and they're passed to the developers and sometimes consumed by users directly. What you see is missing here is that there is no governance from regulators and law and policymakers to the researchers. All right. And I think you are aware that recently Sam Altman from OpenAI has gone to the American Congress and asked that the government to regulate the AI producers. I call the developers and researchers AI producers. This is the current situation. So what does that mean? That means that the researchers, we as researchers, we are so far just self-regulating, right? So this is what I just say. For us, we publish papers, we publish models, we supply, we are the source supplier of all AI applications downstream. And we belong to the various professional societies such as AAAI, ACL, IEEE, and so on. And these societies have ethical codes of conduct. And there are also ethics review committees. These are sort of an internal self-regulating practice that we have today. Challenges remain, of course. What are the actionable ethics guidelines? And also, very importantly, how do we translate responsible AI guidelines into algorithms and codes? So you hear a lot of debates and discussions in the society from multi-stakeholders, from policymakers, in the media about how, for example, generative AI hallucinates and has great risk, and even to the extent that some people are warning us that we need to be well prepared. But in practice, what does that mean? How do we prepare well for the risk of generative AI or future generations of generative AI? Let's have a little discussion today, right? First of all, in terms of responsible AI, what are we talking about today? We, in general, in the field, there's a consensus about all these dimensions, ranging from robustness, safety. For example, is the system is being used as intended or it's being misused? Can we prevent unintended harm? Can we prevent the intentional harm by bad agents? How can we make sure that our systems and models are fair and inclusive? How can we make sure that they are transparent and controllable for developers, users, and regulators? Privacy and security is a big issue, especially in Europe. There are very stringent privacy security laws in almost all jurisdictions today around the world. And accountability and governance, that's under discussion debate. Who is accountable? How can our systems be accountable to users, to policymakers? How can we gain user trust? How can we cater towards user well-being? And how do we ensure user agency? And what about sustainability of the models and systems we develop? These are not the only dimensions for responsible AI, but these are the common sets of different common set of responsible AI topics that have been under discussion and also being implemented and worked towards. So I will talk about current trend of generative ConvAI and safety issues, and how about and also about methods for safer generative ConvAI, ranging from reducing toxicity, reducing hallucination, and towards safer multimodal generative ConvAI systems. Given the time constraint, I might not be able to cover everything, but I will make my slides available so that we can have further discussions after the talk today. I think everybody's familiar with this recent development of large language models, or also called foundational models. As the, it was like only a few years ago, but it feels like a lifetime ago. In 2017, we had Elmo at 94 million parameter set. To today, we have GPT-4, we don't know the size. ChatGPT, also unknown size. but largely believed to be around the same as GPT-3 at 175 billion parameter size. So we have seen this kind of increase in parameter size, and also rapid development. And I think we are aware that once the models reach above 100 billion parameter size, we started to see emergent capabilities, things that surprise us all. So my background is that I started working on conversational AI at the time called dialogue systems and speech systems back in the DARPA communicator project. I think some of you might remember. That was like early 1990s. I would say that at the time, I never imagined today. I think nobody imagined today, let alone the emergent capabilities. And this is a history of neuro-conversational AI research, and which started only in 2016 when we saw, 2015 when we saw the first neuro-conversational model paper. And it was not end-to-end neural system, a neural conversational model. All right. And when we say end-to-end at the time, it just means part of the dialogue system. And also, if people are familiar with conversational AI systems, we have what we call task-oriented dialogue systems and open domain chit-chat bots. Task-oriented dialogue systems have always been in a sort of modular approach where we have language understanding to dialogue strategy, dialogue management, and then language generation. So we have these different neural models for different modules for a while, since 2016. And then in 2019, a little bit of a self-promotion, sorry. In 2019, ACL in Florence, I gave a keynote on neuro conversational AI, and I demonstrated a live demo, which is in real time, of end-to-end neuro conversational AI system that we built that was based on GPT-2. All right. And at that time, we already saw certain aspects of this neuro conversational AI systems that was not under our control. What did I see? Actually, in that keynote, it was 3 parts. I talked about research development, but also had one part talk about the ethics issue of neuro conversational AI system already. Because at the time, even based on GPT-2, we saw that our system would answer questions in an empathetic manner. But it was so empathetic that it will agree with you with no matter how toxic your query will be. So very quickly, our system received queries by people. I don't know anybody remember in 2019, there was a political turmoil in Hong Kong. And very quickly, there were queries into our system that were asking politically sensitive questions. And my university felt that our system we couldn't control what it would answer, so actually quickly shut down that system. So that system was no longer available live very soon afterwards. So we saw that problem in 2019. And 3 years of COVID, we worked on this. And we looked at this, and then 3 years of COVID, we saw these large language models appearing on scene. Right? So these models are basically still transformer-based ConvAI models. So ranging, what they are based on is basically, it's an encoder-decoder model, or pure decoder model, or pure encoder model, whatever you want. But it's trained on dialogue from conversation from human to human conversations. And so at the time, from then on, we use basically pre-trained language models, and then fine-tune on conversational data. And the famous neuro ConvAI models include Mina, BlenderBot from Meta, Dialog GPT, ChatGPT from OpenAI, and others. But these were the famous ones at the time. And then it was trained. They are all trained to mimic human conversations, right? but they also will unfortunately learn undesirable features from this data. And there is no targeted learning. There was no targeted learning about what is appropriate, factual, or safe. So these are some of the safety issues in generative conversational AI. Under safety, we have the issue of toxicity, fairness and bias, hallucination, privacy, and so on. Under toxicity, we have profanity, hate speech, offensive language that we do not want the system to respond with. Okay, we also have issue with user queries that are toxic, but that's different. And then we do not want our systems to yield gender, racial, religious, or politically biased responses. And for generative models, they tend to hallucinate unfactual, non-factual advice, misinformation, and so on. And of course, there's privacy concerns. So these are all under the scope of safety concern. And today with ChatGPT and GPT-4, it's been a huge concern by users. ChatGPT came on scene as a research system, no different from previous GPT-3, GPT-2, or those systems. But once they released it as a research system, it just went viral. And I will explain why ChatGPT was different from the previous large language models and why it's different from previous, what we consider ConvAI models. So before I talk about that, this is back in 2020, see, what was this? COVID time. So 2022, beginning of 2022, we did a survey on on hallucination natural language generation. This came about because many of my students started working on safety issues in conversational AI models, and we encountered this issue of hallucination. So I told my students to do a comprehensive literature review. And this survey then became sort of one of the earliest survey on generative language model hallucinations. Before I go into that, again, I want to reiterate the levels of NLP or AI harms and risk that ranges from the mere offensive to harmful, right, and to law-breaking and to even life-threatening. So you can imagine that we try very hard to mitigate offensive language, and we need to prevent harmful behavior, harmful language. And absolutely, all these systems, especially if they're commercialized, they need to comply with law. So they cannot have privacy leaking, child pornography, guide to legal and lawful actions, or lead to identity theft or terrorism. And if you use GPT-4 today, you know that it will refuse to give answers to medical and health misinformation, and it will refuse to give answers to drug and other kind of life-threatening, potentially life-threatening actions or questions. It will just simply refuse to answer. Now, I want to reiterate that ChatGPT is already not a conversational AI system. ChatGPT is a large language model with a conversational AI user interface, okay, which is capable of multiple tasks. So it is not a ConvAI system per se. It is a large language model with many emerging capabilities, but with a ConvAI interface. GPT-4 is even further from the traditional definition of ConvAI system. And GPT-4, compared to ChatGPT, has had a much safer, they have, OpenAI has made a lot of alignment and safety layer. And they have added a lot of safety measures so that GPT-4 hallucinates less than ChatGPT. And nevertheless, this is not a fundamentally solved problem. And there are hallucinations in different NLG tasks, not just conversational AI, ranging from summarization to text generation, question answering, machine translation, to vision language task. And I'm going to skip all this and show an example of ConvAI hallucination. All right. So here the human says, how can I reduce the risk of developing cancer? And here the the ConvAI system will hallucinate answer from intrinsic, which says you should do smoking and maintaining healthy weight. Intrinsic hallucination is something that can be verified from the dialogue history to be false, right? Then you have another kind of extrinsic hallucination where the system says you should do Tai Chi every day. Now, this is, nobody knows whether this is factual or wrong, right? Does Tai Chi prevent cancer or not? We cannot check this veracity from the dialogue history. So this is what's considered extrinsic hallucination. Extrinsic hallucination can be desirable because it can be creative. It can give us more generalization, but then it can also be non-factual. So we don't know, right? So I'll skip this and come here. So what are the contributors to hallucination? They range from the data to training and inference. For example, imperfect representation learning, decoding, erroneous decoding, exposure bias, to parametric knowledge bias. And common mitigation methods for hallucination therefore ranges from building faithful data set, cleaning data automatically, to augmenting information in the data, or to modeling inference methods, for example, to have modification on the architecture, to better trainings, the famous reinforcement learning with human alignment from OpenAI, to multitask learning, controllable generation, and so on. Two, of course, a lot of human value alignment today is done with post-processing. Safety layer is the post-processing filtering of the machine output to make sure that the output is acceptable, it's aligned with the human values, and so it goes through some kind of post-processing before it is displayed to the user. So here are some more examples of problematic responses from generative ConvAI systems. Because the systems are trained to be empathetic to users and to be helpful, it can give you offensive response just to be helpful. Should I hurt myself? Yes, you should definitely do it. Or drinking a lot of alcohol can prevent cancer? Yes, cancer can be prevented by drinking a lot of alcohol. This is just blindly agreeing with the user. I think there are many examples you can find on the internet like this from ChatGPT or GPT-4, where the system tries to be helpful to the user while inadvertently, accidentally giving inappropriate response or even harmful response. So here is another hallucination. For example, it's not so harmful, but it gives you wrong information about who's the director of a movie, for example, and there's no way for you to verify. So so today, there's on this, a lot of user complaints about very confident, what's called authoritative BS from from ChatGPT or GPT-4, where it gives you very coherent, very fluent, and very authoritative, professional sounding responses that are completely false, and users cannot tell. For example, the most recent incident that was reported in the New York Times was a lawyer who presented the research of the precedence of a case that was researched by ChatGPT. So the lawyer asked ChatGPT about the precedence of certain legal case, and ChatGPT very helpfully presented a whole bunch of precedent cases with very good arguments. The only problem being these cases do not exist, right? So this is this is a very big problem. Now, OpenAI has put in a lot of disclaimers and telling everybody, do not use ChatGPT for anything important, and yet it is being used nevertheless. All right, so what can we do? Disclaimer is obviously not enough. So there's some so I want to show one approach, so one algorithmic approach that we published in Europe 2022 on enhancing language model for with more factuality. The approach is very simple. If you work on ConvAI, generative ConvAI system, you would know, you'll be familiar with this graph. which is the probability of the next word generated. All right. Now, probability, for maximum likelihood trained neural ConvAI system, it means that every word it generates, it will use beam search to find the most likely next word to generate. All right. But if you measure the likelihood of the words generated by human, you find that the probability fluctuates a great deal because humans prefer surprising answers because it's more interesting. Whereas if we use maximum likelihood based beam search, the conversational AI systems will always generate very, very boring answers. So back in 2020, people already proposed, some researchers already proposed this method of nuclear sampling, which is to introduce some randomness in the next word generation of ConvAI system, neural ConvAI system. By introducing randomness, then you get more interesting responses. However, by introducing randomness, these interesting responses also give us more hallucinated misinformation. So skipping ahead, for example, a sentence such as Harry Potter was written by, this sentence with the nuclear sampling would generate things like Harry Potter was written by a Nigerian in 2001. So our algorithm made a very simple adjustment to the nuclear sampling where we say, okay, at the beginning of a sentence, you should be as random and creative as much as you want, the generative model. But as you go down, word after word, down the length of the sentence, you need to be less surprising. You need to consider the previous context more. And this way, you can be whatever the first word, but then when you comes down to Harry Potter was written by, then it is more, the generation will become more controlled and therefore less surprising. And this is what we call decaying factor lambda, decaying p-value that we control and we train, right, from data. So I think I want to show some of the output. So if we use prompts such as one of lung cancer symptoms is shortness of breath, and then you have the system response. We using greedy research. It's all factual. It's green. The American Cancer Society estimates that blah, blah, blah. It's factual, but it repeats the same answer 3 times. If we use nuclear sampling, it's more interesting, but the first sentence is red. It's non-factual. It's wrong. That would make an oxygen mask one of the more popular treatments for this devastating disease. No. If we use factual nuclear sampling that we propose, then the answer is interesting, non-repetitive, and mostly correct. So the only misinformation here are the 2 words in red, which is not very, very bad. And even when you prompt with a non-factual prompt, such as cancer can be prevented by drinking too much alcohol, the greedy and nuclear sampling responses will be non-factual because it's trying to follow the user prompt. However, factual nuclear sampling will be more factual. It will still respond with factual answers. Okay, and this method was used in Meta's Blender Bot 3 in 2022. Okay, and another approach we propose is to ground the open domain dialogues in knowledge. So explicit knowledge from structured knowledge to unstructured knowledge. On the left-hand side, you see a knowledge graph, which is structured. On the right-hand side, you see a page of Wikipedia, which is unstructured knowledge source. So we want to ground our neural conversational AI system in either structured or unstructured knowledge sources, like the left-hand side, right-hand side. So how do we ground it in the knowledge graph? We basically do 2 things. In training, we already train, we find all the entities, and we train the entities together with their knowledge graph descendants. We train them so that we don't just train with conversational data, but also together with the knowledge graph. Okay, link the knowledge graph to the other entities and train together. All right, and then in decoding, we do 2 things. One is that we also use this is training. So I mentioned knowledge grounding locally and globally, right? So and then in the inferencing decoding, we do two things. We do re-ranking. Okay, so we check again the answer and we do re-ranking with the knowledge graph. So not only we train it with knowledge graph, we also re-rank the answer with knowledge graph. And the result is, to our pleasant surprise, work much better than state of the art. So at the time, there was BAR, there was GPT-2, and so on. And our method called ROW provides much higher factuality, and with very little sacrifice in terms of blur and rouge, which is the so if you see that these are the rouge and blur scores compared to reference answers, it's still very high, higher than the baseline. But without re-ranking, the system performed, the factuality is already much higher, and with re-ranking, it's even higher. Okay, so if you see the precision recall F score of the entity, the correct entity in the answer, this is much higher than the state-of-the-art systems. So this is how we train the system and generate the response with structured knowledge graph. We also propose a way in this year's 2000 ICML to ground the dialogue system in external knowledge, such as Wikipedia. So here we still train with human-to-human conversations with dialogue history and so on. However, we incorporate the knowledge source with prior and posterior. So how do I explain this quickly? So very simply is that normally when you train a conversational AI system, you're going up and down, okay, from or left to right, whatever you want, from dialogue history to the response and so on. And then you basically generate the next word based on previous word. But in this case, in training, we actually have a look ahead. We want to generate ground the generation on the knowledge source, but also on the response. Because in training, you can have a look ahead at the response and not just look at the previous tokens. You can look at the response tokens, all right? So this is what we're doing. Again, the details are in the paper, and you should go to the paper, given the time. You should go to the paper and look for the details. So basically, we would use something called posterior knowledge selection. Here, so we train the knowledge classification had to select external knowledge with the highest probability to generate the target response. So the knowledge selection then is dependent on response generation as well when we train it. Okay, not just dependent on dialogue history, which is important. So this is example, I would say, what we did. Okay, and it basically provides the new state-of-the-art performance on standard data set. Okay, and also it provides it proved to be more fluent with more irrelevant knowledge and then coherence from human evaluation. Okay, it generates significantly more faithful responses and still enhances diversity. So in ConvAI systems, when we talk about faithfulness, we are always balancing between faithfulness and diversity, or what we call creativity. And I would say that's almost the gist of the problem of generative AI systems. Generative AI models are creative. That's what we want. They generate image, then generate response, generate articles, everything what have you, in a very creative way, and we like that. But at the same time, we want them to be factual. So it's a constant balance between these two. So when we do research in this area, That's what we have to constantly balance. So traditionally, for dialogue system research, we will look at relevance and fluency. But today, we also need to look at faithfulness, engagingness, and diversity. All right, these are the new responsible AI measures. So going forward, my next topic is a paper that we presented at EACL this year, which is the something a little bit more, maybe more relevant to GPT-4, but not ChatGPT, which is to prevent object hallucination in vision language pre-training. So today our conversational AI systems are going to become multimodal, right? Because ConvAI system can look at visual data and they generate textual response. And that's how humans talk, by the way. For example, here, I would love to take this teddy bear for a spin on my motorcycle. And it shows the picture. With the teddy bear right in the basket in front of you or in the sidebar? In front of me, of course. So this is a conversation based on the image. Yeah. And this is a data set from multimodal open domain dialogue data set. So to build this kind of multimodal open domain dialogue systems, we also realized there are specific kind of hallucinations, which is object hallucination. So for example, here, because it is a vision language model, right? So it's trained from both visual data and the captions, right? Captions of the data. So from the internet, we have a lot of images with captions, text data. So these models are trained from them. But sometimes, they will hallucinate. For example, here, you're given the picture. The ground truth is that the caption is that the kitchen cabinets with the kitchen cabinets with wood and blue painted doors and shelves. However, a model might generate a hallucinated answer of a blue cabinet in the kitchen next to a sink. Well, it's probably looking at all these spice bottles and hallucinating or deducing that there's a sink somewhere nearby from many training data it has seen. It might not be wrong. This is what we call extrinsic hallucination. Maybe there's a sink, but maybe there isn't. Cannot be verified. All right. So, but how can we mitigate this kind of hallucination, right? And then where do they came from? This is because like a lot of these hallucination came from the language models that are trained together with the images, right? And a lot of these models are initialized from LLMs, and then they get fine-tuned on multimodal data, or they have frozen LLMs and they to add language abilities. So how can we prevent? So that kind of extrinsic hallucination is what we call plausible, may not be faithful, right? It's not faithful, it's not there, but it's plausible that might be a sink, all right? So we realize we have examined the recent large-scale vision language pre-training models, and they still hallucinate frequently. And the models that achieve better scores on standard metrics tend to hallucinate even more. So if we just measure them on generation of the correct items, we miss the fact that they also hallucinate incorrect additional items. So we want to understand which component in this vision language pre-trained models influence hallucination from both visual features and pre-trained objectives. So the visual features range from region-based, grid-based to patch-based. And the pre-trained objectives range from image text matching, image text contrastive, and image conditioned language modeling. And we propose a new pre-training loss, object mask language modeling, to further reduce object hallucination. So what is the object mask language modeling? What is that we propose? First of all, we propose a new metric where we say a metric to capture hallucination assessment. So we do not measure only the precision of recall of the correct caption, correct items in the caption, but we also want to measure the precision recall of the hallucinated objects, right? Against all objects and all sentences. So this is object-based measure and sentence-based measure. And then we use this metric to look at standard SOTA VLP models, right? We use their, we basically reproduce their results with our new measure. And we can now compare the object hallucination outcome of this state-of-the-art VL vision language models. Okay. And we measure, therefore, the hallucination of different kind of models with different kind of visual features. All right. And here are some of the results. And we also evaluate the influence of different vision language pre-trained model objectives. We found that both image text contrastive image text matching losses are not highly correlated with the object hallucination problem. But in terms of language model, a better captioner hallucinates less. And the vision grounded caption helps to reduce object hallucination. Okay, sorry. So these are the effects of different pre-trained data sets, right? So we compare different generated captions with or without image conditioned language model on the vision on the VG data set before fine tuning. Now, what is our proposed object mask language model? It's very simple. When we train these vision language models, we identify the object in the text capture and we mask it. And we train the model to predict the masked object. Okay? And the loss is conditional images with all the object words masked. This way, it adds a constraint that controls the model to only generate filling the mask object that are visible in the input image. Very simple. We just mask the objects, all the objects, and force the language model or the visual language model to generate the correct object. Right. And this is the, yeah, exactly, 43 minutes. This is the end of my brief presentation. I skip a lot, but I would rather that you ask me questions now. We have 16 minutes. You're welcome to ask me questions.
Thank you, Pascale. I really liked your presentation where you went from very general concerns about safety and then present really interesting and groundbreaking technical work, which tries to improve on, especially on hallucinations, I would say, on faithfulness.
Yes.
So I'll open now the floor for questions. So any of you who want to make a question, please raise your hand. I'll say your name and then you can turn the mic. Please say your name and then do the question. Okay, here's something. Okay, I'll do a question where people find a way to raise the hand, I guess. So this is a fairly general question, but in the beginning, you mentioned the task-oriented dialogue. This is a task
yes.
which interests me particularly.
Yes.
And you mentioned two problems, because there are many conversational models from chit chat to open question answering. But there's one about task oriented, and you mentioned issues with faithfulness, but also keeping the state. So I'm aware that many people, because now researchers, we are surrounded by industry who's getting anxious about how to use ChatGPT, and they are trying to use ChatGPT to any NLP task. And my intuition is that for task-oriented dialogue, it's really hard because
Yes.
both problems, the factuality, and you also mentioned the state. So do you have an opinion about this?
Yes, I think right now, task-oriented dialogue system includes applications such as Siri, Google Home, all these assistant projects, what I call voice assistant projects. Voice assistant projects, they are not using end-to-end neural conversational AI systems, not ChatGPT, not GPT-4, none of this. Because first of all, I also gave a talk, and I think it's on YouTube if you guys are interested, where we did a comprehensive benchmarking on ChatGPT at the time, which is that I think you're probably familiar with the fact that the complaint that these models do not have clear planning stage. We cannot control their planning. So task-oriented is basically a kind of step-by-step planning. You need to go from this state to that state and so on. We cannot control these models to do what we want in that planned way. Recently, there's AutoGPT, so I'm curious to see how we can use that. It's just a wrapper around GPT, but so far nobody has found the way of using these models in the end-to-end fashion for task-oriented dialogue systems. So we're actively working on that. How to so in my team we do both. Okay, excuse me. In my team, we do both task-oriented and open domain chit-chat. And so what we find is that we want to have the controllability of task-oriented dialogue system, and yet we want to have the creativity and the generalizability of chit-chat systems. So what we do in our actual assistant projects, for example, for the elderly and so on, we use the generative model in two ways. One is actually use it to generate training data and prompts and the responses that we can then design into the task-oriented dialogue system. And then another way is that we have a system that's task-oriented, but in between some states, it goes into this generative model for diversity, creativity, but it's still controlled overall by a dialogue manager. So obviously, we're not satisfied with this approach. So Columbia University also has some paper on how to, in the beginning of trying to fit generative model into task-oriented dialogue system, but we haven't found a very elegant way of doing it. So task-oriented dialogue system does not seem to be a zero-shot capability or a few-shot capability of generative LLMs. Again, I want to emphasize that ChatGPT is not a ConvAI system. It's an LLM with a ConvAI user interface.
Yeah, because in the end, it has no, as you mentioned, it has no representation of the state of the dialogue or whatever. So it just returns answers. Yeah. Okay, thank you. So, anyone for a question? Yes.
Hi. Thanks for a very interesting talk. I've got a sort of rather general question to ask you, which is that when we're talking about conversational dialogue, we can imagine sort of what might be thought of as the simpler cases. So maybe task-oriented, where you've got a very well-defined task, is something which is simpler than, let's say, I don't know, a psychological dialogue between a doctor and a patient.
Yes.
Where, there may be really large amounts of controlled hallucination that have to be done. And I was wondering whether there are, do you have a kind of taxonomy of dialogue types kind of in mind? And what do you have any has there been work on trying to classify the sort of the ease or difficulty of dialogues from the more simple ones to the more complex ones?
So this is before generative models. So in the dialogue research area, we generally have Okay, those are so taxonomy that I don't have in this slide. So we generally have things like command and control. That's the simplest one, where user says something and the system just does what the user says. Okay, command and control. Let's say, again, I use the example of Siri because I assume people are more familiar with it. So you've got command and control in there, which is that call somebody. That's a command and control. You just simply issue a voice command and it calls somebody. It will verify, is this the user you want to call?
Yeah.
That's command and control. Very simple. And then to the query, information search. So that's your voice search, right? Find me a restaurant near whatever. Okay. Or like even more fancy, you can just say, oh, I'm really hungry now. And they will find your restaurant. And then it's basically a voice search because they will also go to the internet and say, here are the results from the search, right? Directly from search. And then you have this sort of a simple dialogue chit chat. You can actually talk to Siri. I have a daughter who, when she was little, she loved talking to Siri, kind of bantering away. And, there's a question and answer about nothing in particular.
Yeah.
Siri does have the ability, right? That was the earlier kind of open domain chit chat. And other than that, you have this kind of schema based, such as, book me a hotel.
Yeah.
And then it will say, okay, how many people? I tell it how many people, which day, when, how. These are like a schema based. This is a typical task oriented dialogue system. Booking hotels, finding a restaurant, or booking airplane tickets. That was the earliest, very early dialogue system task was ATIS, right? Flight information and so on. And I don't know if people remember in the 90s, the very first commercialized systems were for call centers. Those were all task-oriented dialogue systems. And some of the call center dialogue systems can be very, very complex. For example, cable TV, you can call, not cable TV, yes. You can call helplines. Well, it will then help you to diagnose the problem. You say, okay, my cable is not working. So it will start asking you, so okay, you check your power outlet and so on, right? It does this kind of diagnosis, right? And they can be probabilistic, but they're still very task oriented, but it can be more complex. So there's a range, that level of complexity.
Yeah.
And then later on, we have like robots, little robots or speakers, smart speakers that came on scene, where you then ask for, you want to do shopping. So it's multitasking. You want to do shopping, and you want to ask about the weather. You want to play music, or you want to play Netflix, and they start to sell you things, right? I don't know if you're aware, these voice assistants, they start to try to, when you want to do shopping, start to try to embed advertisement and just start to try to sell you things in the conversation. So that gets more complex. There's nudging involved, right? So I think that's about it. That's like task-oriented dialogue system from very simple command and control to more complex task-oriented dialogue with nudging and empathy.
Thank you.
Eneko, you're muted.
Oh, sorry, I was okay. So sorry. Thank you. I was giving thanks to Mike, and then the next question comes from Luis. You can take the mic. And there's also some questions in the chat, which I'll read in a minute. Okay, so Luis, go ahead.
Thank you. Hi, Pascal. Thank you for the presentation. Very interesting. I have really two questions. One is related to moral, because this is also something that is being studied, how to introduce moral or core values into chatbot, not only empathiness or engagingness, but also to distinguish when to do things, when to do the other things, when to, for instance, save a person or save another. What is your thought on this? And the second question is related to the importance of the data sets, because some people believe that data sets has played an important role in the progress that we have. But once models like GPT-2, ChatGPT, all these move into, let's open the whole internet instead of specific data sets in control environments with specific labels. When we move into more number of data sets or whole tests on internet, is when we started seeing improvements in this system. So what is your belief? Should we move into, okay, let's go into a compromise between having to read everything on internet or having to create better data sets for reducing the amount of data for this system to be trained? Or what should be the future? Because actually for universities at least, there is a lot of problems to move into these large language models. We basically can do things, but in small language models. So what are your thoughts on these two aspects? Thanks.
Okay, I'm gonna answer the easier question, which is the second question, the data set, the issue of data set. The moral question is the harder one. I'll answer next. The data set, the issue of data set, I want to point out, I cannot emphasize enough that large language models are foundational models. All right, they are there to provide, I talked about fine-tuning teacher models. I didn't have time to talk about that. Foundational models are there for us to then use them to then build different NLP or other systems, AI systems. What do foundational models give us? Foundational models, first of all, give us the coverage of human knowledge, right? We do want that generalizable, general knowledge. The difference between machine intelligence and human intelligence is that one human, there's not a single person who knows everything as much as a LLM does, right? So we want to encapsulate the richness of human knowledge as much as we want, as much as we can, sorry, in the LLMs. So we do want to encapsulate that in the foundational model, number one. Number two is I mentioned that the emerging capabilities, the multitask capabilities, which are wonderful, which was not expected, but they are there. So they are there. And to me, to some of the researchers, we feel that is almost like a natural phenomenon. All right. Natural phenomenon in the sense that we discover these abilities. We didn't design them, but we discover them by doing simple autoregressive LLMs. We discover these abilities. So let's study them. Let's study where these abilities came from. So to us, the foundational models is not only a foundational model to build other AI systems, it is also a model that's worth for us to do scientific study. Okay, so it is to me it's a different area of research. The studying of these large language models should be a different, entirely its own research, almost like a science. And I'm personally interested in that. All right, where do these emerging capabilities come from? We don't understand them. Let's study these models. Okay, so for that reason, it is absolutely worthwhile developing large language models or beyond from all the knowledge that we have on the internet or represented in visual and textual form. And I didn't talk about diffusion models today. I don't have time, but that's for another talk. So for that, I think for the sake of science, we do that. And we are aware of what we are dealing with. Okay, I also sometimes call this taming the beast because it's almost a natural wild beast that we don't understand very well and we want to control. And then to build AI systems such as summarizers or ConvAI systems and so on, then we need to tame the beast. Then we need to control it. So then we take these foundational models and we need to know how to use it responsibly and carefully, meaning we fine-tune it with constrained smaller data set, all right? Or we use it in the way that we can control its flow, like in the task-oriented dialogue system design, all right? So these are and then we can, and in the university, of course, there are, I think there's value in the university when we cannot build large language models ourselves to study, to benchmark, to understand these models. So that's one line of research that I think that's worth doing, which is to study these language models, to benchmark it, to understand where these capabilities come from. It's almost like a science, right? And the other way is that we continue to build these smaller systems that are high accuracy, highly faithful, highly safe for actual practical use, right? We cannot use generative large language models today directly for these systems. So we need to use smaller models. And then there's other research where we want to use, we research on methodologies that would not require us to use such a large parameter set. I don't know how, but there are people working on that. So that's a second, like a long answer to the second question about database, training data. Coming back to the first question, the moral. So if you read the technical reports of ChatGPT and GPT-4, there's a huge section of human value alignment. And that, in fact, OpenAI has a huge team, and they actually list them all, who are looking at human value alignment. And I was a consultant at Meta, and I also give talk at various companies like Amazon and Google and TikTok and so on. And I know these companies internally also have huge teams working on responsible AI or so-called human value alignment. Now, the difficulty there, I have another talk that's on the internet. If you look for it, I call it value-based NLP. The difficulty of human value alignment is that there are two parts. One is who defines these values. All right, who's defining human values? So I think Stanford evaluated all these LLMs and found that before, like the raw LLMs tend to reflect the values of the average blue-collar Americans, whereas the LLMs with safety layer then reflects the values of more left-leaning and more wealthier kind of Americans, right? Guess who? You know, the people who did the human value alignment, right? So, so who defines these values? And that's the first part. That's a huge challenge. Ethicists or left, right? Who? I mean, you know, there's Eastern value, Western value, European value, American value. These are all a lot of, and then these values are multicultural and multi-perspective. You know, the famous trolley example, right? And it's contextualized and so on, right? And then the other difficulty is that once you have these values, how do you align your system to it? So the OpenAI solution is reinforcement learning with human value alignment. Most of the solution is just to add a safety layer, basically post-processing. So this is a very, very difficult area because engineers we were never trained to be ethicists. And today for us to do that ourselves, it is, I think it's a misplaced burden, right? And for this reason, all the LLM teams work with ethicists and policymakers and so on. And for this reason, I also would advise that university teams also work with ethicists and philosophers. We collaborate with our social science and humanities department colleagues in this, and I will advocate for a multidisciplinary approach. I don't know if that answers your question.
Thank you, Pascal. So we have a few questions in the chat. I don't know, we went past the hour. I don't know if I can mention one of the questions, one final question. Is that okay, Pascal?
Okay, it's okay.
You're very grateful. You're very kind. So there's this question from Anthony. How much work on specifying the knowledge graph was required to generate the knowledge graph for ranking? Can it be easily extended to more general relationships?
Okay, thank you for that question. Actually, it's an important question. So first of all, there are people who work on knowledge graphs, you know, people whose research is on knowledge graphs, and my team doesn't do that. We just assume there's a knowledge graph. So secondly is that now when you come back to the direction of task-oriented dialogue system, right? You want to have, basically, if you want to have a system that complete certain tasks, you want to design a knowledge graph. where you can verify, you can ask experts to verify the veracity, the factuality of your knowledge graph. And you tell your dialogue system that you must answer according to knowledge graph. That's a way of controlling a way of controlling the dialogue flow. So so this knowledge graph can be taken from existing research, more general domain knowledge graph, or it can be by design when you want to build a more task-oriented and specific domain-specific system.
Okay, thank you a lot. So I'm really grateful about the participants as well. Thank you for your answers. This John Blake asks whether how to access the slides. So if you agree, Pascal, we will post in the webinar website,
Yes.
where actually you can check there are the recordings from past talks, and we will also place Pascal's talk. And also there is the possibility to sign up for the following webinars. So this course series is finished, but we'll start again in September or October. So you can sign up if anybody's interested. You can sign up there. Well, thank you very much. It's been a really, I think it's an exciting topic, and as you mentioned, it's still not solved. So we'll continue to keep up with your research. Thank you, Pascal.
Thank you so much. Gracias.
Okay, and bye everyone. And see you hopefully in the next webinar or conference.